In the last lesson, we weaponized our spaceship. We learned how to bundle data using transforms and use the spacebar to spawn flying laser bolts across our map. Right now, your laser flies straight through your procedurally generated asteroids like ghosts. In this lesson, we're going to dive into collision detection. We'll write the logic that allows our objects to physically feel each other, causing our laser to vaporize itself and smash an asteroid out of existence then when we collide with it. All right, let's begin with some basic programming terminology. Now, to make our objects impact each other, we need to understand how game engines handle physical boundaries. And we do this through things like collision channels, on-component begin overlap, and destroy actor. Collision channels are ways of categorizing every object into a specific team or channel, like pawn, static, or projectile. This allows you to write custom rules such as lasers should pass cleanly through player ship, but they must explode if they hit an asteroid. And then we have on-component begin overlap. Now this is a built-in event node that acts like an invisible tripwire. The exact millisecond another physical boundary cuts into our capsule component, this event fires off a signal saying, hey, something just entered my bubble, now do something. And then we have destroy actor. This is a built-in function and it completely deletes an object from the computer's temporary memory, which is great for memory consumption. All right, now that we have some terminology out of the way, let's jump into Unreal. Now for a collision to happen, both the laser and the asteroid need to have their physical properties turned on. Let's make sure our asteroid is ready to detect this. Go to your content browser for your BP asteroid blueprint and double click to open it. Look at your top left components panel and click on your sphere, or in our case, our asteroid here. Now I know some of you went with a sphere, I went with a cube, so it's really whatever your mesh component is. Now with this mesh component selected, look over at the detail panel on the far right, and we're going to scroll down until you find a large category header named collision. Now we're looking for a setting called collision preset. Click the drop-down menu, which might say block all dynamic or default, and change it to overlap all dynamic. All right, so why did we select overlap instead of block? Objects behave like solid brick walls when they're marked as block. They'll physically bounce off of each other or they'll stop dead in their track. By marking as an overlap, objects behave like they're invisible lasers and they're tripwiring. They can pass straight through another object, but once they trigger or pass through, an electronic script fires off when they cross paths. So for like a fast-paced 2D arcade game, overlap gives us the perfect control without any weird glitches. Alright, let's go ahead and compile and save this, and then we'll just close our asteroid tab. Now let's open our laser blueprint and teach our laser bulb to look out for targets. So down at the bottom, open your BP laser blueprint editor. In the top left components panel, click on your capsule component. With the capsule selected, look at the details panel on the right. Just like the asteroid, find the collision preset dropdown, ensure that it's set to overlap all dynamic like we did before. Now we want to scroll all the way down to the very bottom of our detail panel where you'll see a green list of buttons. Now depending on the version you have, mine are not green. You can see they're white here, but if you're working with an older version, they might come up as green. And we want to find the name, the one that says on component begin overlap. And we want to click the plus icon here. Now you can see here that Unreal instantly jumped over to our main event graph, which is here, and placed a brand new dark red event block node. So you can see it's with our other ones here. All right, let's zoom in on this node. If you look closely at our new node that we just created, on the right hand side it has several of these blue pins, and they're holding data about when our laser crashes into something. So one of those pins is other actor. Now if we just connect the destroy actor node straight to this event, the laser will blow up the exact millisecond it spawns because it's overlapping your player's ship. We have to filter out the data so that the laser only explodes if the other actor is an asteroid. So let's drag out a wire from other actor, and then we're going to release it, and we're going to look for the word cast. And what we're looking to do is cast to BP, and we're looking for BP underscore asteroid here. All right, just to give you a little bit more terminology, and I promise the vocabulary and stuff will get less and less as we go through, but as we're starting out, it's always good to have this sort of stuff. So what exactly is casting? Casting is a programming check that answers the question, are you who I think you are? It takes a generic object pin, other actor, and asks, is this specific object a copy of BP asteroid? If yes, the top execution pin fires. If no, the script stops dead in its tracks. All right, so let's go ahead and destroy the asteroid if our laser hits it. So let's go ahead and drag our pin out, and then I'm going to essentially search for the word destroy, and we're just going to grab destroy actor. All right, what we're doing here is by leaving it to target self, we're actually deleting the laser bolt when it collides into something. So what we want to do is we want to drag out an additional destroy actor here, or I guess we could just hit Control D, save us a little bit of time, and then we want to wire this execution node into here. This time, under our target pin here, we want to drag out a wire backwards from that pin and plug it directly into the BP asteroid. So as BP asteroid here, and I'm just going to double click this and then just reroute our sort of the flow of our these wires, our execution here. So what's going to happen is it's going to destroy the laser, and then it's going to destroy the asteroid that we're casting to, or that it grabs when we hit it. So just to rephrase that, so when the laser capsule overlaps something, in this case it's checking if the object is an asteroid, it'll delete the laser itself, and then it'll delete the specific asteroid we ran into, the BP asteroid. So let's compile and save this. All right, let's test this out. I could see that there could be a error issue, so let's go ahead and press play. And I'm going to hit the spacebar. Now, it looks like our ship is still not working. And I want you to hit F8, and I want you to look around your map and see if you could figure out why. Pause it and see if you could fix it. So here's kind of an image of what the issue is and why our lasers are not colliding. All right, did you figure it out? If not, it's okay. We're all still kind of learning Unreal here, but let's go ahead and stop this. What's happening is in our GM asteroid, we have this spawn transform location on the z-axis, which is set to 0. But when we start our game, I'm going to press play here, and then I'll hit F8 again, and I select my ship, it is actually much higher than these other ones. Now there's a bunch of ways we can do this. We can set the start position of our player start to 0 here, and then it's all zeroed out. But what I'm going to do is, because I like a little bit of buffer room from the ground, because in case I want to put an image here or something like that as a background, I'm just going to copy this 150 here, and I'm going to go back into my GM asteroid here, and I'm just going to use that as my Z location. So now when I compile and save this, and I press play, we should be able to shoot our asteroids, and they should delete. That looks pretty good. All right, so let's save our work, and let's do save all. And let's jump into what I think would be a pretty cool challenge for this lesson. All right, so here's our challenge. Right now, blowing up a giant planetary boulder looks just like it's blowing up a tiny pebble. They both just vanish instantly. In the classic arcade game, shooting a large asteroid causes it to burst, opening up and spawning into 2 medium-sized asteroids in its place. Can you think of a way to make the asteroid split? So here's a little bit of a hint. Instead of putting all the destruction inside the laser script, what if we went inside BP asteroid, created a custom function called explode, and used knowledge from the last lesson on spawning an actor from a class 2 times at its current location right before it destroys itself? All right, give this a shot. Don't just fast forward to the solution, which I'm going to go over in a moment. All right, I hope you guys figured it out, but if not, that's completely okay. So let's go to our content browser and open up our BP asteroid. And then look at the left-hand side, and then in the My Blueprints section, go to your variables, and go ahead and click the plus sign, and let's name a variable called size. And it's going to be an integer, so let's make it an integer, and we're going to name this size. Always, to get your default value to show up, you got to compile and save it. And then we want to set its size to 3. Now let's go ahead and create the explode function. Same area, go to My Blueprints, look for your function section here, and then create a new function called explode. And again, this will take you right into the explode function in the and in the graph here. So we're in our event graph, we have explode, now we're inside the explode function here. Now look at the left-hand panel, and you'll see that your explode function exists here as well. Okay, so I'm going to hold the B key down, and I'm going to go ahead and open up a branch. And if you recall, a branch is the ultimate decision-making block in visual scripting. It's like an if statement. It looks at the red true-false condition, which is here. And if the condition is true, it fires the top execution wire. If it fires false, it does the bottom one here. So let's go ahead and connect our purple explode execution pin. And then we want to drag our size variable into the graph. And we're just going to get the size, which is currently set to 3. All right, so I'm going to drag this out, and I want to grab a greater than symbol. And inside it, instead of 0 here, we're going to do 1. Size is greater than 1, and we're going to plug this right into the condition block. So as long as size is greater than 1, it's going to fire off the true. If size is not greater than 1, it's going to fire off a false. All right, so let's drag a wire out from our true execution node here, and I'm just going to type the word loop. And what I'm looking for is a for loop, not a for each loop. So let's type, we'll just do for loop. There we go. So we want this flow control for loop here. Make sure not to select the for each loop. And for our first index, we're going to do 1. And our second index is going to be 2. This forces our loop machine here to run exactly twice, splitting out 2 shards. Now we're going to drag out a wire from the loop's white loop body here, and we're going to search for spawn actor from class. I'm sure you're slowly seeing this come together. So it's going to fire off the first index 1, it's going to loop again till it reaches 2, and it's going to run this twice. Now think for a second, what class do I want to select from our dropdown here? And if you guessed BP underscore asteroid, you guessed correctly. That's what we're going to be exporting out here. Now, we want to right click on our orange spawn transform here. We want to split it to a struct pin. And what we were looking for here is we're looking for our location, rotation, and scale here. Now, I want these pins to materialize exactly where the parent rock died, right, where the laser hit it. So I'm going to right click and I'm going to do get actor location. And you're like, well, what actor am I getting? Well, we're getting the BP asteroid, right? Because we're getting the self actor location. We are in that. And we're just going to wire this directly into this transform location here. Now I'm going to compile and save this. There's an issue. So right now, our loop will spawn 2 normal size asteroids, which are the default size, which is 3. We sort of need to create a math rule into the new shards telling them to be 1 size smaller than their parent, so it looks like they were split into 2 pieces. So let's look closely at our spawn actor from class node. At the bottom, you'll see a slot to change its size. We need to expose that variable so essentially our printer or our spawn actor can see it. So so make sure that you compile and save your graph. All right, let's select our size variable. And over here on the details panel, we want to check the boxes that say expose on spawn and instance editable. So here's instance editable and expose on spawn. All right, let's expand this as well. Okay, now mine did not have a size that appeared. I had to right click on this and I had to hit refresh nodes. And what you'll see here is because we made this variable instance editable and expose on spawn, our spawn actor BP asteroid here, which is, it's this asteroid here, actually has this variable in here. So make sure you compile and save that. You select the node and you refresh the node. And now you should see an exposed size variable here, which is size 3. All right, so what we can do here is we can grab our same size variable here and just type a minus sign. And we're just going to use a math operator that's the operator here for subtract. And we're just going to subtract 1 from that. And we're going to wire this directly inside of the size here. So now we have a little more control over size, -1. So if you decide, it won't be hard pressed to 3, we always have control over this size here to adjust the variable. So now we're going size 3 -1 is 2, and we're pushing a 2 inside of here. All right, so what we have to do now is, now that our pieces have been successfully spawned on the scene, the original parent rock needs to remove itself from the map. So what we want to do is, here's our completed for loop node here. And once this for loop finishes, it runs and it spits out those two pieces. We're going to go ahead and go from completed here, and then we're just going to destroy this actor. Now, you might be wondering, well, okay, so we did all this for the true branch. What if our size was not greater than 1, like a tiny pebble? So let's go ahead and take care of that. So I'm going to see if I can maybe drag this. We'll compact this stuff a little bit here, just kind of cleaning up. And actually what we can do is, I think we could just drag this false and put it in the same destroy actor node. So if it's this way, we're spitting out two pieces. If it's already a small little asteroid, we'll just destroy it right away. There's no reason to break those into even smaller blocks. So let's compile and save this. All right, I promise, we're in the home stretch. Our explosion function is built, but our laser script itself is using the old destroy actor node to delete the rock directly. So let's swap it out for this new tool that we created. So if you don't already have BP Laser open, open it, and notice that we have a these destroy actor node here. And at the end, we are targeting the cast the blueprint, right? So like right now we're destroying our laser, and if you recall before, this is what destroys our asteroid. Let's go ahead and select this last destroy actor node, and then let's delete that. And now what I want to do is drag a wire out from the one that already exists here, or you can, if this is, you know, I'm going to hold Alt to kind of show you something new, but if you can delete them that way too. But we can drag out another node this way, right out of our BP asteroid, and we could just select or look for our explode function. And I'm going to still do the same thing here where I double click and just kind of control the flow of these execution pins so it looks cleaner. And I'm going to wire this directly into here. All right, let's compile and save that. And moment of truth, AR. Oh, they're getting bigger. Let's see what the reason for that is. All right, so the reason why our cubes were scaling up versus splitting, and I'll go through the solution in a second. It's not that bad. So like right now you can see if I shoot certain ships that are above a certain size, it actually splits them. So if I click on shoot that guy, let's see if I can find another big one. It'll actually stack two cubes. We'll work on that stuff next. But if I shoot this cube, see how there's a little cube there, but if I shoot it once and I shoot it twice, it's actually destroying two cubes. They're just stacked on top of each other. Later we'll do some physics collision where it'll like explode out and move. But right now we're just spawning those two little cubes and they just happen to be spawning on top of each other. So if we look at our BP laser here, this all pretty much looks the same. What we're modifying is our explode function. So if I click that, here's our explode function. And I changed size to a float. And the reason for that, if you remember our random function that we had before in GM asteroids here, this random function, what it's doing is these are both random floats in range. And the asteroid that the size variable we made was an integer. So that was kind of a mistake on my part. And so what we need to do is let's just kind of adjust this. So first I want you inside of BP asteroid, I want you to change the size to a float. And I want you to set that size to 0.5. And the reason for that is because if you recall way back in our previous tutorial, our asteroids were too big. And so we set the scale between 0.1 and 0.5. And when I set the size to 3 in this tutorial, I was thinking about it as 1. It'd be between 1 and 3. I forgot that I didn't adjust that. So anyway, so just go ahead and change that. And then on our random float here, so set on our random float and range here, here's 0.1 and 0.5. Go ahead and just wire that into all four of these. And then that way all of these will be the same size, right? And as they spawn the asteroid. And then in our asteroid here, remember this is spawning the asteroid itself. In this one, we're spawning the little asteroid additional pieces, right? The two pieces. And so for this one, we want to select that same size variable. We want to make sure it's set to 0.5. And then instead of a subtraction node, so you might actually have to delete both of these, by the way, and just redo this and drag this out and do greater than. and then make sure that it's greater than this way, and then wire it in here. And I want it to be greater than 0.3, which is kind of the halfway point. Let's do 0.3. There we go. And then you're going to have to select this as well, and then you have to refresh the node. That way you get it as a decimal. And then what I'm going to do here is my size is 0.3. And then what I want to do also is I want to divide it, whatever the current size is, in half instead of subtracting that. And so what I do is I divide that by 2, some just basic math here. And I wire this into here. And I'm going to wire it into all of these spawn X, Y, and Z transforms here. So what that does is whatever we end up with, right? Because from that size, which is the biggest is 0.5, whatever we end up with, this is going to divide in half. So compile and save that. Now the issue with this is if you feel like you want to make it, you want to go in here and you want to change the size here, right, from our min to max. So say you're like, well, 0.5 is a little small. I want my asteroids bigger. You're gonna have to go in and remember to change. You change this to 0.6. You'll have to, 0.3 might be fine, but if you make it like 1, you might change this to 0.5, and that's really the only thing that you'll change. So I'm going to compile and save that. That's really the only things I changed in here. And now when I go inside here and I press play, and I shoot anything that's of a specific size, you could see it spawned 2 asteroids, and I shoot one, I shoot the other, and it destroys them. And there's our solution.